everybody. My name is Kattge, and I will be talking about the OpenTraits network and the Plant Trait database. However, before I will talk about these two initiatives, I would like to briefly introduce myself. I'm working at the Max Planck Institute for Biogeochemistry in Jena, Germany. And my main task is the coordination and data management in the context of the Plant Trait database. I'm a member of the OpenTraits network, and I'm a co-chair of the GeoBon Species Traits Working Group. And in the context of the Species Traits Working Group at GeoBon, we are very much looking for trait data, monitoring change of traits over time. And that's why I'm pretty much excited that the native bee monitoring RCN may consider to include traits in their monitoring strategy. The OpenTraits network is a global decentralized community of researchers and institutions focused on standardizing and integrating trait data across all domains. It has developed a registry of trait datasets and a best practice guideline, and both can be found on the OpenTraits website. It's a global network of trait initiatives across domains, and it's about sharing. It's about sharing knowledge, concepts, methods, protocols, code, and workflows, and to some extent also data. The trait community is by default organized by the domains, because people working on corals know each other, they publish together. People working on fishes know each other and publish together. The same for people working on birds. And the basic idea of the OpenTraits network is to link these different domains and make exchange about knowledge happen. And actually there is some commonality across the different domains. And for first, I would think it's the basic understanding what are traits. Traits are qualities of entities. And this has been established by Mongal et al. And introduced into plant trait ecology in 2017 by Garnier et al. The entity in this context is an individual organism or a part of it. The entity could also be something else, like the ecosystem, but then we do talk about different things. And the quality is anything that can be measured on that entity, but Viol et al. Stated, let the concept of traits be functional. Examples for traits are then leaf area, the area of a leaf, or the color of the flower visited by a bee. And in this context, this color of the flower would, from my point of view, be a behavioral trait of the bee. The second is, the second commonality across domains is the understanding that traits are observational data. And here measurements, different measurements on an entity are aggregated to observations. And this has been formalized in the context of the oboe ontology. And most of the recent trait databases that have been developed are on this basis. And the first one, like this, was actually the TRI database. And this was published in 2011. The TRI initiative actually started in 2007 as a combination of the Fast Track initiative on refining plant functional classifications of IGBP and Diversitas and the Max Planck Institute. And we initiated a network of vegetation scientists with the mission to develop a global database of plant traits to support functional biogeography and modeling vegetation dynamics. The Plant Trait Database Initiative has a steering committee that hasn't changed since the beginning and receives funding from the Max Planck Institute since 2007. The network coordination and database management is done by Gerhard Böhnisch and myself, and we do receive a lot of service by the IT service group of the Max Planck Institute. We have different researchers helping us from time to time to develop tools and data sets. And last but not least, the TRI network of TRI members. At the moment, we have about 1,100 contributors of data sets and about 10,000 people who have requested data. Trade data are shared via the TRI plant trade database via the data portal. And in the context of the data portal, there is the opportunity to explore the different trades, to request trade data from the TRI database or the TRI file archive, and to contribute data to the TRI database. And when we developed the TRI database, we made two decisions for the database development. And the first decision was to keep the threshold for data contribution low. People can contribute their data as they have. They don't have to reformat the data to any kind of standard format. And the second is that we provide the original data to the users, complemented by quality-checked, harmonized information. And for this, we have developed a pretty much sophisticated integration workflow, which obviously starts with the dataset import. And then we do some complementing of the data. First, adding harmonized information for taxonomy, names of traits and ancillary data, units and values. And then we calculate also mathematically related traits. And then there is a large block of data quality management, which ends finally with the we are asking for feedback from dataset contributors. And only if this feedback is positive, we release the new version of the TRI database. By this, TRI has evolved to a global database of plant traits. We have included about 800 original and integrated data sets and such that it is a second generation of data pooling. The development of the TRI database started in 2007 with a call to the community to contribute data sets. And in blue, you here see the number of data sets integrated into the TRI database over time. And the gray bars indicate calls to the community to contribute new trade data sets. The red line indicates data requests. It starts slow, but then in 2014, 2015, we decided to allow people to make their data sets public via TRI, and this increased the number of data requests a lot. And in 2019, we, with the agreement of the data contributors, set the data sets CC by default to be available from the TRI database. And in yellow here, you see the number of publications with involvement by the TRI database. And actually, data sets and publications are related to the left axis and the number of requests to the right axis. So at the moment, we have about 25,000 requests. And actually, at the moment, we receive about 10 requests a day. This finally led to a global database, version 6, with about 15 million trade records for about 300,000 plant taxa and about 40,000 sampling sites all over the world. With this, I would like to finish my talk and thank you very much for your attention. Please keep in mind the website of the OpenTraits network and of the TRI plant trade database.